Hello everyone. Today we are going to see how we can design a scalable online auction platform that can accept high frequency building on the scale of thousands to millions of bits per second. This is a very interesting question, and I see a trend where a lot of FAANG and equivalent companies are asking these questions to all of the engineers who are interviewing and also engineering managers. This is an interesting question, and I see even some seasoned engineers making tons of mistakes. So let's get to the video and see how we can build something that can scale and that can also handle a lot of bidding happening concurrently. Okay, so this is the prompt that will be given to you during the interview. So just take a moment to read. So pretty straightforward. We are going to build an auction system that must handle high throughput, ensure fairness, and maintain strong consistency. Anything that involves financial transactions, that involves something related to money, then the fairness and consistency are something that are expected. Okay, so let's get started. So first we will break these down into simpler product requirements or functional requirements. So let's just get started. Okay, so I'm going to write my functional requirements. Okay, so this is an auction platform. That's good. So what does that mean? Users can create new auction, and users can place bids. Users can follow auctions and see the latest bids in real time. What else can we do? Yeah, I think that's pretty much covers. We can say maybe at the end declare a winner. So this is pretty good. After this, you can align with your interviewer to see if they want to add something else. That's all. Once you clarify this with the interviewer, then we can pretty much go and cover maybe any other non-functional requirements that they want to focus. So here they have already mentioned a few things. So one is obviously scalable. We have said thousands to millions of bits per second, and we can also assume that the system should handle about say 1 million concurrent auctions and thousands to 1 million concurrent bids per second. So yeah, 1 million instead of concurrent, say we'll just say 1 million bits per second, right? And they've clearly mentioned that strong consistency, so we'll just add that. When it comes to seeing bits, we want to ensure strong consistency, and that's okay. That is the only place where we want consistency, mainly. Other places, you create a new auction and I see it maybe a minute later, and that's probably okay. Not okay, but it's okay if there is some slight delays, but we want to ensure really strong consistency when it comes to bids. Okay, comes to bids, done. What else they've said? They said ensure fairness, no late bids, so that's fine. That's kind of part of users can create new auction, and so yeah, we'll just say when the declare a winner, no more late bids. That's fine. Anything else you want to ask here? So when it comes to consistency, and anything that touches money, you want to make sure that it has high durable system or fault tolerance. So you just say durability, which means we don't even want to lose a single bit. Okay, if we lose it, then that means the system is not really good. So we can not acknowledge, and that's fine. When I say not acknowledge, say the system crashes, then the user also knows that their bid didn't go through, so they know, they get a notification, and in that case they can retry. But we do not want to wrongly acknowledge and lose a bid. So that's very important for us. So losing no bids. What else do we need? I think we have pretty much everything. So durability, obviously, like, that covers like fault tolerance. We said less latency. So latency, say we'll just say 200 to 300 milliseconds when it comes to like seeing the latest bits. So I think we have a good list of non-functional requirements. Again, confirm with your interviewer to see if they are okay with this, and if they say yes, that's it, we can move on to the next one. So for the next item, we will talk about the core entities that we want to like add to the system. These will be like the foundational entities. So let's just go talk about the entities that we want. So always just take a look at this one. So here we'll be able to like anything that's in capital letters, those will be your entities. So we have an auction, and we will have bid, and we have users. That's pretty much it. And if you want, you can also define some items in the auction. So we'll have an ID, we'll have name, or we'll have a description. We can have an item creator, that would be a user ID, and we'll have a end time. This could be optional, or we can just like say by default an auction goes for a few days or something. You can always do that. And auction may have some the item media. So optionally we can do something like item media URL, and obviously we will have like a start price. These are good. And as for bid, we will just have what is the auction ID. We'll stick with one format. I think for now we'll just like stick with this auction ID. That's good. Bidding user ID, so bidding user ID and bidding price. This should be good enough. At this point, I mean, you can add timestamp, but we're just like looking at like the top level items. And for user, you don't even have to go deeper here. You can just like say it has all of the user metadata the system needs. All right, so let's get into the design, and we will start some design, and we can also like in parallel add any way of communication methodologies at the top here. Okay, so we will start as usual. We'll start with the client. So this would be most likely web, or if we are thinking something like eBay, there could be also an app. It doesn't really matter. And the client usually talks to our gateway. This gateway covers everything from authentication to routing to rate limiting, logging. Everything else can be covered by this gateway, so that's good. All right, so let's move on. Okay. Okay, so we have a client and we have an API gateway, and now we need a service that does stuff for us. Okay, so first we want to like create a service that can create new auction. So we can simply call it, at this point we will just like call it an auction service. Okay, and our API gateway would talk here. So for this one, we can just like this is how our APIs would look. Okay, so here this could be a post, and it would just say something like create auction, and then it would have a body that has all the necessary details here. So it can have description, it can have item details, and price in cents. You can also add currency. This would be the starting price. So all the details that we need, we can like have here. And give me a second, I'm just gonna move these things around. Okay, give me a second. Okay. All right. And in most of the cases it can just like simply give 200, but if we also want an image media, then it can just like, you know, say partially it's accepting, and then it can also like return a pre-signed URL where the user can upload any images, and after that it would just like give a 200 saying, hey, yes, it's all accepted. Either way, it's not a big deal. We can like just like, you know, talk about that to the interviewer. Okay, so the first client says like, I want to create an auction. It goes to auction service like, you know, adds an entry in the DB. And then once it creates the auction entry point, it would just say yes, the auction item is done, and it returns the so it goes through the pre-signed URL. So obviously, like, you know, we can also say that there is a an S3 if we want. That's really like, you know, it's not such a big deal. So we just say S3 where it has any item media, and the auction service has access to this one, but users would directly upload to S3. We can just say that, you know, using the pre-signed URL, and that's okay. Okay. And then it returns the, at the end of it, it would again like return the auction ID to the user. So that's good. And once the auction ID is written, that means the auction is like fully created here. Okay. So for the next one, user can place bids, and user can follow auctions and see the latest bid in real time. So for follow auctions, you know, just like going in a bit out of order here, we can simply reuse the same service. So if a user wants to follow, then all they need to do is like just get auction, and they can pass the auction ID, and that's it. This provides this gives the auction metadata information to the user. So with this one, we can just like simply say the auction object is written that has all the necessary details for the user. And so this auction object or auction metadata, it can contain all of the necessary information, including like the ID, description, item, and the latest bid. It can also have the latest bid, but here is a big problem. So the latest bid can go stale just like that, because we need to keep on updating the user. And for now, we can simply say the user, that the client does poll every few seconds, once in every few seconds, and we just like refresh it. That is definitely not a scalable solution, but for now, just for like this sake, you know, just to get to the high level system design, we can just simply say the user would keep on polling, and we will like, you know, refresh the information. That is okay. And next, users can place bids. So let's get to this. For this one, we can add a separate service here. Why separate service? Because like, you know, bidding is a very core piece, and having a separate service gives us easy way to scale things, you know, and also clear separation of logic. So let's go with the separate service here. So bidding service. So user places a bid, and they just like say, you know, say something like post bid, and so they send, you know, we can simply like have this like this, post bid, and we can say, you know, it would have all the necessary information. So what would this be? Auction ID, and price. This is the one price. We can again say price in cents. It's fine. So that means I'm posting my bid and this is my price in cents. I don't have to send the user ID because like it's already authenticated, so don't do that. Okay, cool. So the bidding service comes, the bidding service receives the request. It does some quick validation, making sure that the auction ID is like authentic, making sure that the auction ID is like still open and not closed. And if it all looks good, then it would just check if this price is bigger than the current winning bid. And so how would we do that? So how can we do it's I mean, right now if you go with the regular this particular model, then you'll have to get the auction ID which you have already. So then you have to go to the bid and say, hey, get me all the bids for this auction, and then after that you will find the maximum bid, and then you will have to see if this price in cents is greater than the maximum bid. So that can be a bit lot. So what I would probably make a small change here is that for every auction you can just like pretty much add here, so we can simply say latest winning bid ID. So by just adding this one particular field, you can do a simple lookup. Just look at the latest winning bid ID and check the price. If the price is greater than, we can confirm this with the user. Can people have multiple, do we want to still accept the bid if it's same as the latest one? That's totally fine. But for the sake of simplicity, we can simply say, hey, I'm gonna accept the bid only if it's greater than the price. If it is greater, then we will add this to the DB. We'll create an entry, we'll update the winning bid ID with this current bid ID, and we will tell the user client that yes, we have accepted your bid and your bid is currently the winning bid. Or we can simply tell them that no, we have to decline your bid because it's not greater than the winning bid. So we do that. So one thing I would suggest here is you discuss this with your interviewer. You'll just tell them that, hey, can I still add this bid record? Because in many systems they want you to probably keep track of all of the things just for auditing purposes. You can ask them that. It really doesn't change the much logic here. You'll just like create an ID, but you will not make a change. Maybe you can like add a status saying at some point that persisted for just auditing purpose. You can like also add a simple field here, so it's not really a big problem here. Okay, but our case is pretty clear, so we just do this, and let's move everything. One second again. Okay, this is good. So then what do we have at the end? Declare a winner, no more late bids. How do we do that? We can simply, I mean, there are a lot of ways to go about it. You can like add a separate worker that just it's a cron job that every few hours it just like runs over and checks if the auctions have closed, and if so, then it would like take the last bid, and then it would just declare the winner, and it would like push notify the latest winner, the latest bidder, and then it would just tell them. That's one option. Another option is while creating the auction itself, you clearly know when the auction would end, because we can either optionally accept an end date, or we can simply say, okay, the option stays open for like say 3 days or 5 days or something. Whatever you decide, you can create a job to run at that particular time. So I think most of the queuing system that actually has a particular way to like configure to run a job at a particular time. So you can just do that. For now, we'll just like say a cron job that actually runs and declares the winner. So once it runs, and then it actually declares the winner, cron job. So we'll just like say okay, this is looking ugly, but I think it's not too bad. Okay, so let's get to the meaty pieces, right? So we have all the basic stuff that we need. So now let's go into some of the requirements for mainly here the scalability, right? So how do we want to actually scale the system? Can the system scale for millions of concurrent bits? And then we'll also talk about like the millions of like max up to like thousands to millions of bits that usually come out like per second. Okay, so for a lot of auctions, what we can do is, so we have a gateway. Gateway can have load balancer, so a lot of clients can talk to the load balancer, and we can add more auction service as we need. If you use something like AWS, you can just like say, hey, when the system reaches 70% capacity, then spawn a new service. That you can always do. So this can handle, you can just simply scale, add more systems, so that way the service is like it's a separate microservice. We can easily scale it, not a problem. And the auction service directly talks to the DB. It's pretty quick persistent, so it's no big deal. If you want, we can also decouple this by adding like a separate Kafka, where the auction service writes, and then have a persistent service that just like persists stuff to DB, and then give notification to client. But that should be okay. I mean, at this point, I think this system would scale, because even if you have a millions of say 1 million auction running at any given point, because like some started today, some started yesterday, on a daily basis, at best we can say, okay, I'm gonna like create like 10,000 auctions per day, and our systems should be able to scale that much. So it's really not a big problem when it comes to like just creating auction service. um, let's say how we can do this for our bidding though. So here we have the second bidding piece. You can have way too many bids coming in, and that can be a problem. The first problem we can see is like number one, we don't want to lose any bids. So right, so the bidding service comes and then it validates, and then after that it checks and writes. But there is a chance that you just like have way too many bids coming in and service doesn't scale. So here you can, if you see closely, you can see two problems. First one, a bidding service might lose a bid. That's a first problem. And second problem could be, there could be multiple services receiving bids for the same auction, and they could run into race conditions, which means they just might like override things. So we want to look at these things and we see how we can solve. First one, we don't want to lose any bids. So similar to the previous the auction service, we can actually try and add a Kafka here. So let's just see how we can go about it. So the API gateway, so what we can do is, let's just like add a small producer. So this producer is very lightweight. At this point, it doesn't even have to do any validation, but you can just simply check maybe if the auction is still alive, but it doesn't even have to do any of that. So the API gateway shares this to producer, and the producer actually write directly to Kafka. Okay, so what happens here is, so we write to Kafka, and we can short it by auction ID. So when there is like too many auctions, it's like it's written to like different queues, so we don't overload it. and our bidding service, again like sharded by auction ID, it just like consumes from Kafka whenever at its own pace. So that way we decoupled it. So we acknowledge clients only after writing to Kafka. So once we write to Kafka, we tell clients that, hey, we received your bid. We haven't processed it, but we just received the bid. And then it should be the other way around. And then when the bidding service, if it's too busy, it can wait. And whenever it's free, it will consume from Kafka, it will process the bid, and then it will let the client know that, hey, we have processed your bid and whether we have accepted or not. So we split it into two pieces. First one just like receiving, and the second one is the processing piece. Okay, so we solved the first problem. The second problem. So second problem would be the consistency piece. So what happens here? We try our best to split the bids by auction ID. So that way one bidding service processes all the bids from the auction. So it does it, but still there can be like, it's still a big service. There can be like multiple threads running. So what can happen is, so let's say there is an auction like this, right? So we have something like, auction ID. It can say something like, 1, 2, 3, 4. And the latest winning bid would be, let's write it, it's bigger. Okay, so, and it just says that latest winning bid, it can say something like, 100.00. And now the bidding service receives two bids. The first one is like for say 120, and the second one is for 110. So in this case, both the bids reads the number as $100, and both the bids threads think that, okay, the current price is greater than the highest bid. So the first one writes 120 and the second one writes 110, and then we eventually like, get into a corrupted state, because ideally we only one should win. So how do we fix the problem? So it's a classical race conditioning problem. There are a lot of ways to go about it. You can go to a very strict extreme where you just say, hey, I'm gonna like do pessimistic logging, which means locking. So at the database level you log, or you can say something like, hey, I'm gonna do an optimistic logging. And how would you go about it? You can simply do something like add a separate field called version. So let's just say updated version, or just simply say version is fine. So the version can be something like 35. So we will also add this here. This version would actually help us while having multiple services like, or multiple threads trying to rewrite. So how would it do? So it's the same two bits come in, 120 and 110. So then the first one would like read 100, it's good. So it wants to update it. So when it tries to update, what it would do is it would say, hey, latest winning bid equals 120 and the version equals 35 now, and then it will update the version equals 36. So after the 120 is done, so the system will look like this, 120 and then the version is 36. At the same time, when 110 comes to write, it would say the latest winning bid equals 110, and where the version equals 35. And since the version is like updated since then, it would fail. And when it fails, what it can do is like it can rewrite by rechecking things, or it would just like completely drop the bid, saying that, okay, this bid is like no longer like big one. So for example, it would rewrite if the order is different. So the first bid that comes is like $110, and we update the system to 110 and version is 36. And 120, when it comes to write, it would say latest winning bid equals 120 and version equals 35. The version is no longer 35, so it would check, and then it would say it's fine, I'm still bigger than this one. So it would say 120 and version equals 37. So this way we are preventing the race conditions. It doesn't really have to do. The another possible option that you can do is you can also instead of like writing db, right, we always usually in most of the highly scalable system we add a redis, and in the redis you also can have like a cached value, and you can write through redis, or you just like use redis and you can have a separate asynchronous service that write back to db. But there is a risk to it because like redis is not durable, it can crash and we might lose the bit. So what I would suggest is evict the redis, write to db, and then update the redis, so that way it's all like clearly done. Or you can also do a locking on redis for that particular auction id, and then update the db, come back and remove the lock. So either way, we just want to like talk about it. Everything has its own trade-offs, you just use that. Okay. uh, and about like regular fault tolerance piece, you want to like have an auction create, the auction service crashes, we don't acknowledge, so the client actually retries and we recreate. And whenever there is a retry mentioned, you always say item potency, that is the key. So the client retries recreating auction service auctions, or the client tries to rebid, we always have an item potency, which means like every time a client submits, you just like either use a signature that is unique. For example, the bidder, the bidding original timestamp that initiated, and the bidding price, you can use it as a hash, and you can use it to check if that was unique, that was recently processed. Or you can also have a client reuse the same id every time it tries, and we can like see if we have already processed the id, so that way we don't ever like multiple times process the same information. Okay, so this is good. And we have one more problem to solve, and that would be users can follow auctions and see the latest bid in real time. During the initial high level design, we just like said users can keep on polling, but obviously we know that that is not a real scalable solution. So in this case, how would it go? So every time a bid comes, we want the auction service, which is maintaining all of the people who are subscribed to an auction, and we want the auction service to know the latest price and update them. So how can we do it? One simple solution would be something like, uh, so we can do this, right? So say I have a pub sub here. This is how it would be like. So I have a Redis pub sub. So this pops up whenever a bid service updates the latest bid, it would write to the pub sub. It would say, it would write to the pub sub. And how would it work is, sorry, 1 second. Yeah, okay, yeah. So it would say, it would write it under the auction ID, and it would say the whatever the latest prices, something like 120, 140, whatever it is. Like it would write under the auction ID, and it would like say this is the latest ID, this is the latest price. And now the auction service, whenever somebody tries to subscribes to an auction, it would have an internal map of whoever the user is. And so this is how it would work. So first one, whenever somebody tries to do this, make this call, it would subscribe to the auction ID in the pub sub. So the auction service would subscribe to pub sub, and okay, so the auction service would subscribe to pub sub under this particular topic, the auction ID. So the auction service, whenever there is a change, it gets notified. Now, the auction service internally maintains a list of all the users who is like watching this particular thing, right? So, and now what protocol we can use to communicate with them? It's a one, if you see this, right? So this is a classic way where you can say, okay, I have a list of clients that are subscribed to an event source. So you can use something called server sent events. So how would that would work is, so you would have an event source and you would subscribe to that event source, and every time there is an update, the server would just flush that update to the client. So anyone who is subscribed to the event source, so you can like, all the so for example, all the JavaScript or any native, they all support server sent events. So you would just like subscribe to the event source, and then after that the client would keep on like flushing any other updates. And at any point, if the client closes the system, then the flush would fail, and that's it. The auction service can like remove that. So the auction service again internally maintain internal map of, so this is how the internal map would look. It would say, it would say something like auction 123, and it would probably have the user information, right? So user 1, user 2, user 3, and stuff like that. Actually, yeah, it doesn't even have to have that. It just like have to have an event source. So auction ID, and it would just say event source object. So it would just do event source dot flush, and every subscribed client would get that information. So that's kind of like abstracted. We don't have to like go super deep into it, but you need to like mention that you would use SSE to solve this problem, and that is very important. So now let's see. We have a client that can place lots of bids, and we are not losing any bids, and we are making sure that there is no race condition. And then we are writing to DB, and whenever there is an update, we write it to PubSub, and the PubSub would actually have a list of all the auctions that are subscribed to the particular auction ID, services that are subscribed to the auction ID, and then it would let the services know, and the services would use SSE to send the users the latest update. And you can actually have a proper React app that would get the information and seamlessly just update the front end. So that way the customers would just like keep on seeing the latest price, so they know what price to bid whenever there is. And one more optimization you can do is you can limit the number of auctions a service can subscribe to by forwarding most of the subscribers of same auction to a particular service. You can mention that. Other than that, we have pretty much like talked about sharding the Kafka, sharding service, sharding the DB, so everything else should be just fine. Yeah, I think this covers everything. Let me know if you have any questions in the comments, and if you liked it, please share it and like it. Thank you.